So resolving a vector, right? So a vector starts with the tail to the tip, right? We can do this graphically if we do everything to scale. So I measured this out. It's actually 58 centimeters. And then I would want to know the angle that it's at with respect to the horizon kind of thing, right? So if I lay this down flat, it looks like we're right at about 37 degrees, right? So we're 37 degrees up from the horizontal. So as we get into real vector stuff, we want to be careful about how we word things. Or let's say this is a map, right, with north, right, for a map, we are 37 degrees north of east, right? Because this would be east. So we are 37 degrees north of east, or 37 degrees up from the horizon kind of thing, right? We're not 37 degrees east of north, because if you're east of north, and that means north, and you're 37 degrees this way. So that would be more up like this, right? We'd be, it'd be 53 degrees east of north, right? 90 minus the 37 kind of thing, right? So I'm 37 degrees north of east. If I want to break this down into its XY components, remember the point of physics is to take a complicated movement and make it simple. So if instead of viewing this at an angle, I just view it as what do I move in the X direction, what do I move in the Y direction, kind of thing, that can make it easier to add them together and that kind of stuff. So algebraically, what I'm going to do is I'm going to turn this into a triangle, and I'm going to do that with colors here. So I'm going to leave my X-axis as blue and my Y-axis as red. So if I do my SOHCAHTOA stuff, right, the 37 degrees is right here. So if I want to know the X, right, that's going to be the adjacent angle. So cosine of an angle is adjacent over hypotenuse. So if I do cosine of 37 equals my X over 58 centimeters. So to get rid of the 58, I'm going to multiply both sides by 58 centimeters. Notice this won't have a unit. Multiply that by 58 centimeters, and it'll still have centimeters for a thing there. So with these calculators, I haven't actually used these for a cosine before, but should just be able to do 58 cosine of 37. Yeah. If you've got a Casio, you usually have to type them in backwards, but I'm going to do 58 cosine of 37 and hit equals, and that gives me 46.3, but really I've got 2 digits here, so I should keep 2 digits. 46 centimeters would be just in the X direction. So if while a plane was climbing this high, a plane 58 centimeters, right, whatever. But while you have moved 58 centimeters total, you have moved 46 centimeters in the X direction. If you do things to scale, if I actually dropped down vertically, which who knows if I did, but look at that, 46. Right? I don't know if you can see that very well, but it's dropping right down there at the 46 centimeter mark. To get very accurate results graphically, you've got to get things big and you've got to measure very, very precisely. I just did all of that in red for the X after I drew it. I flip-flopped my colors, so you're welcome for being horrible. Right? So that's my X. My sine, I'm flip-flopping my colors here, right? So my sine of theta, sine is opposite over hypotenuse, right? SOHCAHTOA, right? So sine is opposite over hypotenuse. So again, I'm just going to plug in. So sine of 37 equals my Y value now over 58 centimeters. And look at that. I'm just going to do the same thing, times both sides by 58 centimeters. And I'm doing this with centimeters because it's not scaled or anything, but you can do it with anything that's a vector. So we can do this, and we'll do this with speeds. You could do it with an acceleration. You do it with forces, with whatever. So 58 sine of 37, again, just type it in, right? So I scared Kelly the other day when I said trig review, and I think I gave her some PTSD, but that's all we're doing with this is trig buttons, right? So 35 centimeters. Again, if I double check that graphically, right, if I'm straight there at all, which I just kind of, here it looks like closer to 36, but how straight is that are those letters and that kind, or are those lines and stuff, but still on the right, same, basic amount there. So when you move 58 centimeters at 37 degrees north of east or up from the horizon, you'll move 46 centimeters east and 35 centimeters north, right? That's another way we can view that. So that's resolving a vector. Resolving a vector is when I take a vector that's in an xy coordinate and break it down to its x motion and its y motion.